Hi, I'm Adam Wagman, and welcome to Arduino from Zero, where you can learn how to create working Arduino projects, starting from zero knowledge about Arduinos, programming, or circuitry, or pretty much anything. So I don't want to keep anyone waiting as to what we're going to make today, so you'll know whether or not you're interested in watching this video. We're going to make a project where we can use a standard IR remote controller to display what button we're pressing on the screen, and I'll show you how it works. Press power. Woohoo, it says power. Play and pause. 2. And you can see that there's an R up there if I press and hold the button, and not if I just press it quickly. And you'll be able to control the display contrast, which is very important. However, this looks pretty messy right now in terms of the wiring, because I used the wires that come with the starter kit. So to make it a little clearer, I'm going to cut my own wires and make it a little shorter. All you're going to need for this project is any kind of Arduino board, a LCD character display, this one's 16 by 2, a little IR receiver, and a 10K potentiometer, which is just a variable resistor. And I've got this plugged into a battery, but you can plug it into your computer. So let me go rewire this thing. Well, welcome back. Thanks for waiting so long. As you can see, I've managed to clean this thing up a little using shorter little wires here. As a matter of fact, I managed to clean it up enough that we even got rid of the need to use this extra big breadboard. And of course, it's a good idea to make sure that things actually still work. I'll press the play button. Whew. Okay, still works. All right, so now I think we're ready to go back to zero and show what parts you need, how we're going to hook it up, how we're going to write the code, and what you might do from here. So in the rest of this video, I'm going to go through all the details from the beginning on the overview of this project, what the idea is, how to wire it, how to write the code, all the diagrams. But if you're familiar with Arduino and you just want to go ahead and create this thing and run it, everything's available on github.com. You just go to github.com/Arduino from zero /IR_and_LCD. You'll see a code button and you can just download the zip file. Everything will be there. Circuit diagrams, code, libraries, all of that. But if you want to see all of the glorious details and start learning, stick with me. So I'm going to spend the next 10 or 11 minutes talking about creating the hardware from the ground up, including details on how you do wiring and how breadboards work. If you're already sort of familiar with all of that stuff and want to skip ahead to learning about the programming, feel free to skip ahead now. So a lot of Arduino projects that you can find are going to basically jump right in and show you circuit diagrams or wiring diagrams and hand you the code. And it can be a little hard to figure out exactly what they are when you're first getting started. Or try to figure out what's going wrong if it doesn't quite work for you. So what I really like to do is to start at a more conceptual level of what is it I want to try to do. So here's I start with a conceptual diagram of the hardware, and what you can see here is really, okay, here's our Arduino board. I want to create something that uses an IR remote. It's going to send a signal to this little IR receiver here, and whatever the IR receiver gets, which is basically a button press, it's going to send to the Arduino, and the Arduino is going to run some code, and based on which button it got pressed, it's going to go and display it on this LCD display, and that's really it. Once I looked into some of the details, I realized I need one more piece here. It's going to be a contrast knob. But that's really all there is to it. So, all right, simple enough to understand so far. I've also drawn down here just a reminder that we're going to use a host computer. It could be a PC, it could be a Mac, it could be a Chromebook in order to send the code to the Arduino in the first place to program it with the code we want it to run. And the Arduino, while it's plugged into the host computer, can also send some debugging printouts that you'll be able to see. That can be very helpful for figuring out if something's working right or if it isn't. Um, and then on top of this diagram, I just wanted to say that, I'm really thinking of this project as a good place to start to do more complicated projects because you will be able to control whatever it is you do with the remote, and you'll be able to have a display here that can show you how things are going, even once you disconnect from the host computer. So that's my simple hardware diagram. And similarly, I want to start from the top in terms of the code. And again, rather than diving into the details, I just want to lay out my logic for what's going to happen without worrying about all the low-level stuff. So all Arduino programs consist of basically two functions. One is called setup. It runs when the board first gets powered on or if you reset it with the reset button. And during the setup, you're typically doing some fairly simple stuff, like you need to tell the Arduino which pins you've plugged which devices into and whether they're going to be inputs or outputs. And the other thing you usually do in setup is to initialize some of the devices that need a little bit of custom setup. The LCD, the display needs to know some stuff. Same for the IR receiver. It needs to get ready to start receiving stuff. So after the setup phase, you have one other thing to write. It's the loop. And basically, this is the piece of code that's just going to keep running forever and ever as long as the Arduino has power. And so really, what do we want this loop to do? We want it to check whether a button is pressed. And if no button is pressed, it's just going to go back and wait for another button press, or wait for any button press. And if a button is pressed, we're going to somehow write some code to get the name of the button. And then we're going to display the button name on the liquid crystal display. And after we've done that, we're going to go back and we're going to wait for another button press. One thing to realize about the loop function is it keeps going back to the beginning as soon as it's done. So this sort of thing could be running thousands of times a second. The other thing that I want you to take away from this diagram is this is really the simple stuff, the basic top-level concept of how the code is going to work without getting into all the details of, oh, how do I specify which pins, exactly how am I going to figure out getting the name of the button from that IR receiver. This is part of the magical thinking of programming. Just write down what it is you want to try to do, and we'll figure out what we're actually going to do to accomplish it later. So, okay, had my hardware diagram. Now we can go to what parts are we actually going to need for this project. Okay, going to need an Arduino board. I'm using the Mega 2560. You can use anything. This project would work with an Uno or pretty much anything else. We have the IR receiver module. That's going to actually receive the signal from your IR remote. We're going to have a liquid crystal display. It looks like this. A little 10 kilo ohm potentiometer. So this is basically a resistor that we're going to need to control the contrast of this display. One interesting thing, depending on what sort of kit you might be starting with, it's supposed to look like this with a nice little stick knob that you twiddle. It may come in two separate pieces, so you may see this piece and the stick separately, and you just stick them together. And then you'll be wanting to use a breadboard. It's probably easiest to just start with the big one because you've got more room to figure out your wiring. And as you saw, I was able to use the little one once I sort of made everything as small as I can, but that might be a little trickier to start with. So one thing to note sort of about the Arduino is it's just got a bunch of connections for pins, and really every device that you connect to the Arduino is going to get connected to those pins, and you're going to end up having to tell your program which pin is which. So if we now take a step forwards, you can see these two things. Oops, sorry about that. So this is the more detailed diagram of what the circuit's going to look like when you actually put it together. This is why I like to start from that conceptual diagram, because you look at this and it's a little bit scary. Basically all those red and black wires, the reds are all the power line. It's 5 volts connected to this spot on the Arduino, and all the black wires are connected to the ground. So basically almost every part you are going to have in an Arduino is probably going to need to be connected to power and ground, and then there may be some signal wires. So for example, here's our IR receiver. It's got a power and a ground, and by the way, I'll explain why these breadboard connections work and how you can tell what's connected to what. And then the IR receiver has one signal line that we're going to have to connect to an Arduino pin there. And similarly, for the display, it's actually going to have 6 things we have to connect to the Arduino. How do I know that? Actually, I stole someone else's example, but in theory, I could have read its manual. It's basically going to have some signals that we don't need to understand just yet for the example. And then some things that, of course, aren't shown here, as I haven't shown, well, you better have your IR remote, and you're going to eventually connect the Arduino to power somehow, and while you're programming it, you'll connect a USB cable right here. And so this is how the physical layout is really going to work. And by the way, I and most other people create these things with a tool called Fritzing, pretty handy for creating these diagrams. Of course, if you're creating your own circuit, you probably just want to sketch it out rather than going to all this trouble. The other sort of diagram you'll see, which frankly looks maybe even scarier than this one, is an actual circuit schematic. And although it looks pretty confusing, the really handy thing about the circuit schematic is you can read the label for each pin that you're going to get connected to and where those go. The schematic here doesn't really necessarily imply where you've physically placed each thing, but it is pretty handy when you sort of are going to have to go through and check your wiring, make sure you got it all right, to make sure that things are going to the right place. So in the Arduino world, pretty much every device you're going to use, like this IR receiver, you're going to need to connect to the Arduino through these pin inputs, which are inputs and outputs here. And how are you going to do it? Well, you guessed it, you're going to use wires. So the device will have, for example, pins like this. And you'll need to connect a wire that, for example, has a female end here and to a male pin that will connect to the Arduino. So I like to color code my wires if possible. In particular, we're going to use, if you see over here, you can see there's a G, R, and Y. That stands for ground, power, and signal in this particular thing. I wouldn't expect you to know that, but basically you find out when somebody tells you or you read the manual. So we'll use red for power there. We'll use black for the ground. And I'm going to use yellow for the signal. That's where we're going to find out what button gets pressed. And now I need to connect the power to the part of the Arduino that says 5 volts. You can see these things are labeled both on the circuit board over here, and typically they're also written outside here, hard to read on this camera, but so I'll plug the power into 5 volts, plug the ground into ground, which is GND, and I'm going to plug my signal into over here, which is pin 2, which is just one of the pins that's available for digital signals. Different pins on the Arduinos have different purposes. We'll talk about that another time. So if all I'm ever going to do is use this IR sensor, really that's all I need to do. I could go ahead and write something that uses that right now. But what you will quickly discover when you want to use more than one part, in addition to this being sort of floppy and lying around all over the place, is that the Arduino typically only has one 5-volt pin. It also has a different power for things that need 3.3 volts. It has a few ground connectors, but that one power pin is going to be a big problem when we need more than one thing. So instead, what we're going to need to do is use something called a breadboard. And what you can see here is the big one that typically comes with most kits. And the important thing to realize about a breadboard is that each set of 5 holes in this direction, those 5 are all connected to each other. So anything I plug into this hole is connected to these other 4 also. And holes that are adjacent to each other are not connected. So if I plug in something there, they're not connected to each other. And in addition to these sets of 5, running along the long edge of the board, all this entire row that's labeled plus here is connected. All of those are connected, and then separately the row below it is all connected. And what these are used for is power and ground. And again, there are 2 on the other side done the same way, one for power, one for ground. And that way, anything that you put anywhere on here that you need to connect to power or ground, you can just connect to any of those 2 strips. And your Arduino, you'll just connect once to power and ground, and it will basically be feeding power everywhere. So if we go back to our little IR sensor here, so I've still got these 3 pins that had gone into the Arduino. Now, one thing I can do is I'll plug this red into the power, black into the ground, and then the yellow I would still plug it straight into the Arduino pin 2. And well, you'd think you're good to go, but just the fact that I called this power and ground doesn't magically give them that. We've actually got to connect the Arduino to them. So again, I'll have to take a wire, which I'll stick with red, to that power strip. And then I will use a black wire for my ground and plug that in here on the Arduino and over here on this strip. That seems a little awkward, right? So what I'll actually do is plug this power and ground on the Arduino into the side that's closer, and then I will connect those to the other side. And again, they don't have to be right next to it because this whole strip is connected, so I'll just jump, that's why these are called jumper wires, over there, and with the power to the power, and here I'll connect the ground to the ground, and now if the Arduino had power, we'd be all set. So this is definitely one way to do it, and it might be handy if I wanted to be able to just go and stick this somewhere far away. On the other hand, I'd like it to be a little more stable for right now, so I'm actually going to plug this directly into the breadboard instead of having it do these. And again, either way will work, and sometimes it just depends on what layout is easier if you're creating your own project. So what I'm going to do here is just plug these 3 wires in directly. And okay, so ground is now over here on the right. So I will be able to take this, make sure I've got it in the right column. And again, I can go to anywhere I want to that's free on that black power strip. The next one is the power, and again, this column is all connected, so I can poke that in there. And then to over here. And now I need to run my signal line here. And as usual, back to the usual slot here on the Arduino. And of course, this now has some advantages. I can plug other things in here. This keeps my IR sensor sort of nice and stable. You can imagine I'm going to want to point a remote at it, so it's handy to not have it flopping around. So now we're going to want to add our LCD. It's a liquid crystal display. It has 16 characters across in 2 rows. So again, it's got pins like this at the back. I could connect a bunch of wires to it, but instead I'm just going to slap it into the breadboard here somewhere. And as I mentioned, there's this potentiometer is going to control the contrast. It's just a twist knob that changes the resistance of the resistor, and that's used to control the contrast here. It's basically got 3 pins. There'll be a power and a ground, although you can make either one either. And then this pin, which is called the wiper, you can sort of imagine a wiper going back and forth. That's the output. Now this is a pin that doesn't go to the Arduino because the Arduino isn't going to process a signal. This is really just a direct electrical connection, so the Arduino doesn't even need to know about it. So I'm going to actually do a little trick here. Rather than having to run a wire to this wiper pin, what I'm actually going to do is I'm going to plug it directly into the column that I need to connect it to. It's actually this 3rd pin over here. It's called V0 if you are able to read these labels. And parts like this go right across the bridge here nicely. So we can just plug that in. And then we'll be plugging this into power and ground. And a number of these goes to power and ground, and the others go to the Arduino. Again, if you go back to this diagram, this is sort of where all of the things are going to need to go. I'm not going to bore you by showing me plugging in each wire here, but those are the connections that will end up getting made. You'll see that a number of them go to power, a number of them go to ground, and then we're going to connect the display that's called, there are pins called RS and E and D4 through D7, and those are going to be the 6 pins that are going to get connected to the Arduino over here. In 3 will be the RS, and 4 will be the enable E, and then 5, 6, 7, and 8 are going to get connected to D4, 5, 6, and 7. So that's it for how to wire this thing up. Next, we're going to talk about the code. So if you finish building that circuit, you'll have something that looks something vaguely like this with your display, contrast knob, IR receiver, and your Arduino board. Now we're going to talk about the code that makes that whole thing run. So I'm going to go through some of the very basics of Arduino programming. Feel free to move ahead if you understand this sort of stuff. So basically an Arduino program is called a sketch, which is written in something called the Arduino programming language, which is pretty much basically just the C++ language. C++ is in very widespread use. It's used by professional software engineers throughout the world. So you're learning a very handy language. And the Arduino programming language gives you some extra functions that are really special for the Arduino. It does things like specifying whether a pin you're going to use is an input or an output, because it needs to know these things. It'll let you read or write a value to a pin. And it can also do things like print debugging messages. There's actually quite a few other functions available you can use if you need to. There's a full reference for the programming language there at that link. And also, in addition to sort of those individual statements like setting a pin signal or saying how it's going to be configured, most Arduino components, these things like the sensors and motors and everything, have a library that somebody's already written for you that lets you use it. So for example, if you've got this LCD display, which has something like 10 pins that need to be written to just in order to display some characters, you don't want to be writing code that says what to do with the signal on each pin just to print something. You want to use the library somebody already wrote. And eventually you'll be able to figure out to write your own libraries too, if you want to use those. So when you write an Arduino sketch, there are a few things that are absolutely and always required. And it's pretty minimal. It's going to have one function called setup and one called loop. Oops, sorry, skipped ahead there. The setup function is just called once at the very beginning when the sketch starts. That's when you turn on the Arduino power, you press the reset button. You can even write code to do a reset, although you probably wouldn't want to in most cases. And then it's going to run this loop function forever and ever, until you turn it off. Sometimes when you're debugging, you might make one of these functions completely empty. For example, you could have a setup function that just shows something on the LCD display and quits right there and just sits there in a loop doing nothing. Okay, so all you need is setup and loop, but for almost any basic program, you're going to see it laid out with a particular typical structure. At the top, you're going to include what's called a header file for each library. That's the thing that's going to have these special functions like print to a display, or get an input from the IR receiver. You'll want to define some constants, numeric constants for each pin. I'll show you what that looks like later. So, for example, if my IR signal, if I've decided to use pin 2 is what I'm going to wire that to, I don't want to use the number 2 everywhere in my program. I'll call it something like IR signal pin. And then that also not only makes it easier to understand, it also makes it easier to change. Like if I realize that 2 was a bad choice because maybe that pin is too far away, when I finally put everything on the breadboard, I can change it and I only have to change one place in the code. As I said, many sensors and other components are going to have a library, and you'll create something called an object in C++. It'll represent that component. We'll sort of be learning by example, so I'm not going to give you the details of the whole language. It's easier to just see what it looks like to understand it. What you usually do in the setup function is you're just going to specify which pins are used as inputs and outputs. Sometimes you'll do things like initialize something called the serial monitor that'll let you see debugging printouts. We'll see an example of that. And then the loop function is really the function you're going to use to do everything interesting. So we're going to go back to our original flowchart that I showed at the beginning of this video. It was pretty simple. And now we're going to see how that turns into each of those 5 little things that I talked about that each program is typically going to have. So at the start, we're going to include the library header. So there's a library for the liquid crystal display. There's a library for the IR remote. We include these two headers. We're going to define some constants for the pens. You can call these constants anything you want. I try to have a naming scheme where it starts with pen, and then some kind of name for the part, like LCD or IR, and then I'm going to name each pen by how it's labeled on the part, and RS is one of the ones on the liquid crystal display. After we define some pens, we're going to create these library objects if we need them. So there's this thing called IR receive that's the object type that's declared in the IR remote library. I'm going to create this object called the IR receiver. I picked that name, and it takes some arguments. In particular, this one just needs the one pen for the signal. For the liquid crystal display, it's going to need to know a bunch of the pins, and you'll see that in the final code. Next, we're going to have the setup function. You'd usually initialize pens, but everything that we needed to initialize was done by these two library objects. And then I'm going to do a couple things in setup. I'm going to have my LCD print ready just so I can see that it's working. And the IR receiver, you need to call this function in order to get it started and ready to receive button presses. And then in the loop for our function, we're just going to use that IR receiver to get a name for the button, like volume up or power or whatever. And then we're going to use a function from the LCD library to just print out that button name. So you can see our conceptual diagram maps pretty simply to the different pieces of an Arduino sketch. Okay, I wasn't quite telling the truth. It's a little more complicated than that to really make this thing do everything we want. And sorry about that. So you really could have written the program exactly like that, except the IR library doesn't actually provide exactly those functions, like get button names. So we're going to have to use the functions from the IR library, which really just give you like a numeric code. We're going to have to write a little extra code to get a button name out of it. Since many circuits, shockingly, don't work exactly the way you expect the first time, we're going to be able to add some debugging printouts to help us see what's going on. Also, I think we're going to want to be able to do more stuff with this project in the future. So we're going to try to add some stuff to the code that's going to make it easier to add more stuff to it later. And then, gee, sometimes as a project goes along, you realize you missed a step. It turns out that when you have an IR remote and you press a button, the receiver library may tell you just that you're still holding down the previous button without telling you what it is. So, for example, if you press and hold the volume up button, the first time the receiver says, you just pressed the volume up button. Then the next thing it says is just repeat, repeat, repeat. So we're going to have to add some code to keep track of things that we're repeating. So now you can actually go for it and try all of this stuff. Again, all of the code, the wiring diagrams, and the documentation like this presentation can be found here on GitHub. Just download it. You can get the code in there. Next, I'll just step you through how you do that if you're unfamiliar with that process. And eventually, we're going to need to show you how to actually well, I don't know, debug, but we're probably going to make that a separate little thing. So if you want to stick around, I'm going to show you just how to actually get that code off of GitHub, get it loaded into the Arduino editor, and actually get it loaded onto that lovely little circuit that you just built. Okay, let's get our code from GitHub and get it into the editor and then onto our board. So github.com, Arduino from 0, IR and LCD. Click this code button, download it as a zip. Once you open this, you can extract it. I won't make you sit through that. Once you do, you'll have a folder that looks like this. And what you'll see is, for example, there's a doc subdirectory, the PowerPoint with this whole presentation in it, the schematic that shows all of the pin connections, the breadboard diagram that shows what it looks like physically. This is a file for a program called Fritzing that I use to create those schematics. You could even edit it if you were going to add something to it. The code has a zip file with our source code, and the libraries, we needed to grab another library for the IR receiver because that doesn't typically come with the Arduino IDE. So now let's go back to our browser. We're going to go to arduino.cc. To get to the editor, we'll go to Software, Downloads, and use the web editor, although you could download a version for your computer. Okay, the first time you do this, it may ask you to create an account. Be sure to use an email where you can get a verification email. So if you've got a lockdown student email, use a different email for that. So we're just going to import the sketch we downloaded. So in Arduino downloads, here in code, we're just going to select that zip file. Successfully imported it. You can see all the code is here. If we just want to compile it without the board connected, we'll say verify. It'll make sure that I haven't made any typing mistakes. That looks good. Now, look over here. I'm going to connect my Arduino. This cable's connected to my computer's USB. And now I can go back here and upload to the board. Not sure why that's interrupted. Let's try again. Every once in a while, those things happen. It was busy for a while. And apparently it's all ready now. And with any luck, we can still give it a try. And there we go. Now, if you want to stick around, I can walk you through some of the details of the code. But you're all good and ready now to go play with this thing and try it out. Okay, but now I will take a look at this code. Again, like we went through in the presentation, you can see those things that I had in the very abbreviated form. We're going to include the header file for that liquid crystal display library. We're going to include the header file for the IR remote. I had included the library with this download. If I hadn't, what you would need to do is to go to libraries and you would have done import, and you would have gone to find this one over here to download it. Everything with these slashes is a comment, so it's just there to hopefully help you understand the code. Here are my defines for these constants so that it's easier to remember or change. So I've got these 6 pins on the LCD, 1 on the IR receiver. I defined a couple of other constants to just say that the LCD is 16 by 2. We have to set that up later. Here are those library objects that initialize the IR receiver, telling it which pin it's using, and the liquid crystal display telling it which pins those are using. Now here's some of the stuff where we go beyond the very simple form I showed in the slideshow. An enumeration is another way of declaring constants, similar to the pound define that created these. So basically here I'm creating constants for all of the buttons on this remote. So I've got 0 through 9, I've got a down, an EQ, the fast forward button, all of those. There's also this special one called repeat. This was the thing I suddenly discovered after trying to run this program, which is it's a special value if you hold down a different key. Okay, so I'm going to need these couple of helper functions I'll write later. One that's going to translate the button. This is the result that's going to come from the IR receiver library that I downloaded from somewhere else. But I want to convert its results, which just have some very weird numeric values. You can see them down here. These are hexadecimal values, so they're base 16. That doesn't really matter, but there are a bunch of big, weird integers that are particular to this kind of remote. You really don't want to have to write that sort of stuff in my code, which is why I convert it to these nice, easy-to-read constants I'll define myself. And I'm also going to have a process button function that you guys could extend later if you wanted to. So in the setup function, a couple of other things that I didn't mention before, so in detail, there's something called the serial monitor, which while you're connected to your Arduino, will let you get messages from it. So for example, I'm going to have some other printouts to this serial monitor down below. So you can see that in addition to printing the button name on the LCD, I'm going to print the button name on the serial monitor. So let's see how that works. Here, I'll press the 2. So you can see that it says 2, and it repeats sometimes. I have a 5. If I point the infrared remote someplace weird so it doesn't get a good signal, I might be able to get it to say, I don't know. Nope, not today. Oh, there we go. If I pointed it so that it gets a really bad signal, it's like, I don't know, but here's the raw code if that was a button from a different remote, and we could add it to our program later. All right, well, let's go back to setup. This code probably actually belongs there, especially if you had a different size display that wasn't the default. The IR receiver library requires you to explicitly enable the receiver to start. And then during the setup phase, I just cleared the LCD screen and printed ready. And these are all functions that are coming out of the Liquid Crystal library. Okay, so here's our loop function. That's the main thing. So this loop will just keep running forever as long as we have power. So IR receiver has a function called decode. It just returns a value that's 0 or 1. It'll be 1 if it succeeded. So if I did decode it, I got some kind of button press. And out of these raw results that are from the library, I'm going to translate it to one of our easier to understand constants. Now I'm going to have to handle the fact that we've got the possibility of a repeat, which the library will tell us. So I say, if this isn't a repeat, so this is the first time we're pressing the button, or it was a quick press, I'm going to say, yes, the last button pressed is the one we just pressed. If it is a repeat, I'm actually going to say the button we're processing is the one we pressed before. Otherwise, the problem is this thing called current button is actually just a special value for repeat, which isn't too useful. So now that I've gotten our constant for button, I'm going to have a function I'll write below. It takes that button constant and returns us a name. Const char star is the type for a string in C++. So now that we've got the button name, I'm going to clear the LCD. It makes you position the cursor for where you want it, first column, first line, then print the name. And if it's a repeat off at the far right, I'm going to print this letter R. And again, I printed it on the serial monitor also. And if the button was unknown, maybe this is a new kind of remote other than the one we got with our kit. sure it would be helpful to know that code so we can add it to the set of buttons we know about. So I have it print that out both to the LCD and to the serial monitor. Then I've got this function called process button that you would be able to use, for example, if you wanted to extend this functionality. And then when we're done, the IR receiver library makes us say resume, so it's ready for another button press. And so here's that process button, and really, I've made it empty. This if 0 basically says ignore everything. It's like a super big comment. But basically, we could have things that take that button value and say, well, hey, if it's the power button, toggle power. Although you don't want to do that if it's a long-held key press, you just keep going back and forth. If it were volume up, you might write some function called turn it up, and same for down, and we'd have this default for doing other stuff. And then down here, we see the details for how I'm getting the button name. So again, this is our easy to understand constant, and I'm just returning some string that means something for each name. So for the volume up key, I'm just putting vol plus. For power, we got power. And those are all just like that. Just in case I got some constant I forgot to add, I'll make it print something weird. And then down here at the bottom is this function that translates from the library results to our button results. And these are all these codes, and these codes can be different for every brand of IR remote. So if you use one other than the one we're using in the kit, you might need to go and find these codes for whatever remote you're using. Okay, well that's the deep dive into the code. So now you guys are ready to go off and experiment. Hope you enjoy, and I'd be happy to hear any feedback you've got on this video and how we can teach people to use Arduinos from 0 even better. Thanks a lot. Bye.